Hi, I'm Sean, and today we're going to be going through a previous probability question. To increase your probability of exam success, go to studyclix.ie.
So here's our question. We're told that when Connor rings Kira's house, the probability that she will answer is 1/5. And for part A, we're told that he rings the house for 7 consecutive days. We're going to find the probability that she will answer the phone on the 2nd, 4th and 6th day, but not on the other days. So for the first day, the probability that she won't answer the phone is 4/5, of course, and we need that to be true. We also need her to answer on the 2nd day, so that's going to be 1/5. And we're just going to keep going through that process for all 7 days, and then see what our fraction is going to be at the end. So that is going to look like this. So she answers on the 2nd, 4th and 6th days, and everything else is just her not answering. So all that's left to do now is just simplify this big fraction. And the easiest way to put this in the calculator is going to be 1/5 to the power of 3 multiplied by 4/5 to the power of 4. And the value of that is going to be 256 over 78,125. So that's it for part A. And that's the probability that she's going to answer on the 2nd, 4th and 6th day, but not the other days. And that is worth 10 marks. So B asks us to find the probability that she will answer the phone for the 4th time on the 7th day. So if she answers the phone for the 4th time on the 7th day, that means that she answered 3 times on any 3 of the first 6 days. So there are quite a few possibilities here about what could have happened. And although you could just go through it all, so maybe she answers on the 1st, 2nd and 3rd day, then you calculate the last 3 days and try and cover all your bases, the best way to do this is actually with a Bernoulli trial. And Bernoulli trials are perfect for when you have a certain number of occurrences within a certain number of trials, but not necessarily any sort of specific stipulations about when those occurrences actually happen. So for part A, we couldn't have used it, but in this case, it's actually what we want to do. So the probability for Bernoulli trials formula here is on this page of your log tables. I'm not sure if it's the same page that you're going to see, but that's the formula and that's what it looks like. And just in case you didn't understand exactly what the formula means, we say that n is the number of trials, or sort of the number of chances, which in this case would be 6 days for the first 6 days. R is the required number of successes, so we want the phone to be answered 3 times within those 6 days. P is the probability of success, which we know in the question is 1/5. And Q is the probability of failure, which is 4/5. So those are the numbers we need to find out the probability that she answers 3 times within the first 6 days. And we're going to plug that into our formula. So that is going to look like this. And if you think about it, this actually makes a lot of sense, because it gives us that we have the phone being answered 3 times and not being answered 3 times, sort of like it was in the first question in part A. But we also have incorporated this 6 choose 3, which accounts for all the possible permutations, so all the ways that you can arrange 0.2 and 0.8 in 6 slots. So it definitely makes sense if you can try and think about it like that. So that brings us to the 7th day, which we can't forget, because this accounts for the first 6 days, and on the 7th day we want her to answer the phone. So we're going to multiply it by a further 1/5. So our final probability, after plugging everything into the calculator, is going to be 256 over 15,625. And that is it for part B, and that's going to be worth 5 marks. So part C asks us, given that Connor rings her house every day for n days, to write, in terms of n, the probability that she will answer the phone at least once. So the best way to do this, and other similar questions where we're trying to figure out the probability of something happening at least once, is to consider what would happen if the thing doesn't happen or it doesn't come true. So the probability that Kira won't answer the phone on the nth day is going to be 4/5 n number of times, because for every day she doesn't answer the phone, the probability will just increase by a factor of 4/5, or decrease actually. So the probability that she answers the phone at least once is just going to be 1 and minus the probability that she doesn't answer at all, which means it's going to be 1 minus 4/5 to the power of n. So that is then our final answer. And it makes sense if you think about it going on for a really long time, the probability that she would answer for the first time on like the 10th day is actually really small, because it would require her to not answer at all on any of the first 9 days. So it makes sense that this probability is going to tend towards 1, because 4/5 of the n will have to go down towards 0. So that's part C, and that's worth 5 marks. So for part D, we're asked to find the minimum value of n for which the probability that Kira will answer the phone at least once is greater than 99%. So we're obviously going to be using what we have in part C. So as we've figured out, this is a probability that Kira has already answered the phone at least once on the nth day. So as we already figured out, this is the probability that Kira will answer the phone at least once on the nth day. So we're just going to allow this to be greater than 0.99. And now we're just going to solve for n. And my favorite way to do this is just first of all, let 1 minus 4/5 of the n be equal to 0.99, and then take the next n up from our answer. And the reason I do it this way is because logs and inequalities don't really play that well together. So this is kind of the easiest way to do it, I would say. So the first thing we're going to do is take away 0.99 from both sides and then add across our 4/5 to the power of n. So that's going to give us 4/5 of the n is equal to 0.01. And now it's just a standard log problem. So we have n is equal to log 0.01 to the base 0.8. And it's clear to see now that n is just basically how many times you've got to multiply 0.8 by itself to reach 0.01. And our answer is going to be 20.6377. So therefore the minimum value of n is going to be 21. And the reason we round up is because we know that Kira answers the phone just once a day. So the first time the probability that she's going to answer at least once is greater than 99% occurs on the 21st day, because the 20th day has already passed. So that's part D, and that's going to be worth 5 marks. And that is it for this question. I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as some other helpful resources to help you revise your probability, because probability tends to be more about your thinking involved rather than learning off any formulas or repeating any processes. So it's very important to expose yourself to as much of these probability questions as you can, which test your knowledge of things like Bernoulli trials and permutations and whatnot. But that's it, and I'll see you next time.